So you got the opportunity from Netherlands itself, right? Or nearby?
Sir?
You got the opportunity from the Netherlands itself, or it's near to that city?
Yes, it's actually a neighboring city, like around 1.5 hours by train. Little far from the place I stay currently, but I think with the public transport we have, it's quite manageable. So.
How are your friends doing? Everyone is in touch with you?
Yes, so yeah, coping up well. I mean, few of them also got a job, and few are still doing their thesis, the final project.
Do all remember me?
Yeah, of course, sir.
I just convey
Yeah,
my
of course.
regards if at all if you.
Yeah, sure, sir. Definitely. Yeah, I talked to Kaushik sometime, and yeah, I talked to the university, and especially the things you do for the university, and it's nice that even students are interested, and the faculty is also taking initiative. So it's really nice.
Harika, are you ready? Hello?
Yes, sir.
Okay, then. You just check your voice.
Sir, audible, sir?
Yes, yes, ma. It is fine. It's fine. Okay, okay.
Yes, sir.
Let us see one more minute, then we'll start. Okay, 5:32, 5:33.
Yes,
We'll start.
yes, sir.
Yeah, it's time you will start. Okay, Girish, are you ready?
Yes, sir.
Shall
Yeah,
we
I'm
go?
ready, sir. Yeah, sure.
Thank you. So once again, I welcome you all, yes, students and your participants. We once again welcome you to this 1 week online international student and faculty development program on role of transportation engineers towards sustainable roads and traffic safety as a part of Road Safety Month. And today we are in on day 3 session, and I would like to request my student coordinator to introduce today's speaker of the day. Yes, Marika, please go on, ma'am.
Good evening, sir. Now I would like to introduce about Girish Kumar, sir. Mr. Girish Kumar SR is a marvelous and sterling speaker who has completed his master's in transport infra and logistics, specialized in networks and design from TU Delft, Netherlands, and Honor Program Masters, specialized in the field of intelligent vehicles, transport and traffic safety from TU Delft, Netherlands as well. He has obtained his bachelor's degree in civil engineering from NIT Trichy. Mr. Kumar was a gold medalist in his bachelor's and a bagged scholar of excellence for pursuing masters at the Technical University of Delft. That's why scholars in 2017 for the prestigious scholarship offered by the German Research Institutes and an IS Scholars in 2016 for the Scientific Research Scholarship to pursue funded research in India. Also, he ranked 51 out of 1.5 million participants in National Engineering Olympiad 2016. Mr. Kumar has secured a diploma in building design in CAD Center India and got to be a data science trainer in German numerical analysis and simulation using ANSYS and Origin Pro software from Technical University of Darmstadt. He was also a data analytic intern conquering the delay modeling and analysis of different intersections and roundabouts in TNO, Netherlands. Later, he held the position of a research assistant and designer for driver pedestrian behavior modeling and designed illuminating crossing system in SWOV, Netherlands, and has also been a scientific researcher and data analytic in master thesis project on behavioral and safety studies of cyclists from SWOV, Netherlands. Mr. Kumar's scientific research project works includes gap acceptance, travel purpose using ANN and machine learning, personality and trust analysis with automated vehicle system, influence of cyclistic helmet use in the Netherlands, road pricing implementation design in the Netherlands. Apart from these, he was a member of Board of Studies TU Delft, Netherlands, and also a member of Scholarship Board TU Delft, Netherlands. His major area of interest deals with the multidisciplinary sectors involving smart urban mobility, thereby analyzing and providing innovative and safety solutions. Thank you.
Yeah, please go on. Thanks,
Yeah, sure, sir.
Girish, for accepting this invitation. Please go on. Thank you.
Yeah, sure, sir. Just my pleasure. And once again, welcome everyone. And thanks, Harika, for very detailed introduction about me. So yeah, it's always a pleasure. Glad to speak about traffic and transport safety. And once again, thanks, Girish, sir, for giving me the platform for addressing young students and engineers. So I'll quickly share my screen. Uh, yeah, the screen is visible. And yeah, so yeah, so for the next around 45 minutes, I'll be discussing about one of the recent projects which I worked with SWOF, the Institute of Road Safety Design. And actually, they work on different projects regarding traffic and transport safety and making it more sustainable and safe for different countries across Europe. And this project was also a part of a European Union project called Maybe Safe, where they measure the behaviors of safe behavior and of different road users, which include car users, autonomous vehicle users, cyclists, scooters, etc. So in this project, I mainly focused on finding the effects of behavioral and safety effects of cyclists and scooters with the use of special type of lane marking called the transverse lane marking. And yeah, the audience might also be wondering what exactly does it mean by a nudge, which I'll explain in the coming slides. So yeah, I'll quickly move on. So I think, yeah, we had a big introduction about me, so I'll skip this part and quickly move on to what are we going to see in this presentation. And also, before moving on, feel free to drop by any questions in the Q&A, or you can just raise your hand or interrupt me in between, because it's really important we understand each and every segment of this presentation, so that to have a very fruitful discussion at the end. So mainly the contents include clearly starting with an introduction and coming up with the background, and then also explaining the literature review and state of art of how exactly I came up with the research purpose and research questions. And then I will also give a very broad idea about the different types of methodologies and conceptual model used. In fact, we used camera surveillance and try to capture the behavior and safety aspects. And finally, of course, it's really important to come up with proper interpretations and how exactly the results can be applied for the future. And of course, I dived a little deeper into policy advices and implications as well, because it's quite important that once we have an idea or a design, we actually tie up with a correct set of stakeholders and try to actually imply the design or the methodology which we used. So that was another important aim of this project. And finally, of course, I will brainstorm a little bit on future recommendations, also highlighting the limitations of this research. So it's a pretty straightforward approach in our plan. So yeah, let's move on. So in this picture, you can see here are the cyclists of Netherlands. In fact, when I landed in Netherlands for the first time, I was pretty amazed and inspired by the way they were dedicated cycle lanes. In fact, I saw a lot of traffic jams also in cycling lanes. And also the number of cyclists or number of cycles is actually much more than the population itself. So we have around 23 million cycles for a population of around 17 million. So a lot of people also have two bicycles, like one for going on a mountain ride or hiking, and one for normal roads. But one important aspect which was a concern was, of course, the safety of cyclists. Because of the huge population and a lot of uncertain movements, especially at intersections, the cyclist road is quite high. In fact, is almost equivalent to the car users, as you can see in this figure. And this was a concern for actually past 10 years in Netherlands. And in fact, the car deaths or car crashes or casualties have come down significantly, but the bicycles and the mopeds or scooters are still quite in the same ranges. So this was one of the important aims in actually analyzing the safety and behavior of cyclists and also scooters as well. So I'll quickly explain what are the key findings from the literature review. So in this figure, you can see a T intersection. So this would be the main concept of study in this research. So as you can see, there'll be a through arm with cyclist A and C. And there'll also be an intersecting arm, which will be called as an intersecting right arm in the rest of the presentation. So in literature, or considering all the state of arts and the surveys which I conducted, it seems that there is a huge safety issue at T intersection. And as you can see, this T intersection is also pretty much unsignalized. So there is no signaling system to actually make them go in an efficient way. Since a lot of cyclist intersection here do not have signals, especially when they're dedicated to only cyclists. And of course, when the cyclist lanes are shared, or actually when they are adjacent to the motorways, then we have signals, special signals for cyclists. But here it's a dedicated T intersection, and it's without signals. So here at uncontrolled T intersections, one major problem was the inverted priority perception. And when I mean by inverted priority perception, as you can see in the figure, it looks like the through cyclist A has a higher priority when he's crossing the intersection. But actually, according to the European rules or the Dutch rules, we tend to travel or keep the right lane, which is unlike or a different scenario compared to the Indian traffic situation where we used to keep towards the left lane. So here, according to the rules, the right turning cyclist from the right arm have higher priority. So basically, the through cyclists have to wait or slow down. But what happened, or with the observation we performed, it seems like the through cyclists do not tend to slow down. or he thinks that he has a higher priority or higher priority perception and tends to go faster. And so that actually creates an increased safety critical situation here, and that's what is being addressed in the study. So the through cyclists tend to speed more and ignore the priority perception. So this brings some safety critical situations. And in this research and also from literature, it is found that surrogate safety measures are something which is also growing up in the research, and they are pretty highly validated, and it's a really good measure for actually studying the safety. So it's a quite huge chapter, actually, surrogate safety measures. So I can talk about it separately for a long time. But to keep it brief, surrogate safety measures are something which are proactive in nature. So before even the accident or the crash happens, we try to study what are the problems or what are the causes which give rise to the safety issue. So being more proactive instead of being reactive, where we actually, instead of studying the number of accidents and why the crash happens after it's happening, this surrogate safety measure application is something which is more proactive. So we tend to understand why exactly the safety critical situation happens and what are the causes of this problem, and why the cyclist or the road user are motivated to behave in a certain way, and try to minimize that already before the accident is happening. So it's a very nice concept which is coming up for the future applications. And also from literature, it's been understood that to capture the safety criticality using surrogate safety measures, there are multiple options which could be applied. But for this research, I chose two things, or two indicators. One is deceleration ranges, and another is a jerk. And why did I select these two, apart from other conventional surrogate safety measures? Is because of various reasons. And also, if you're wondering about what are some conventional surrogate safety measures, so basically, to give a brief idea again, one I can say is the time to collision, and another is post-encroachment time and gap acceptance, etc. So these are the conventional surrogate safety measures. And what happens with these is basically these conventional surrogate safety measures like time to collision. And when I mean by time to collision is basically the time taken for two road users to actually collide if they come in the same speed and without changing their trajectory. So that's the definition of time to collision. So what happens in this is there's a lot of assumptions. So basically, it's assumed that the road users might actually go the same speed, which never happens at the intersection. They tend to slow down or brake or negotiate. And it's also assumed in time to collision or conventional surrogate safety measures that they, at some point, it's assumed that they travel in an unchanged maneuver trajectory. Which what I mean by this is they do not change the trajectory when we want to measure the time to collision. So these two assumptions are pretty much not valid in an intersection, because it's obvious that at intersection, either the road users slow down or try to maneuver. Like for example, the through cyclist A can actually take a right turn, and the intersecting right arm cyclist can take a right turn, or he can actually go left. So there can be multiple complex movements which are not considered with the conventional surrogate safety measure. So that's the main reason of choosing deceleration ranges and jerk as a surrogate safety measure. And I think you might also wonder how exactly can deceleration range give me a safety criticality. And it's quite obvious that if in case there is, imagine a safety critical situation, and the road user tend to either brake harder or give very sudden changes to his braking or speed changes. So it's assumed that if the deceleration is beyond a particular threshold, and as per literature, it's a negative 3.3 meter per second square, it is considered as a safety critical situation. So again, since it's a surrogate safety measure, the accident is not happening. And when the braking is more than 3.3, it doesn't mean that accident is going to happen, but it just means that it's safety critical. So there is a safety issue. There might be a potential crash or a potential conflict. So that's the main idea of using surrogate safety measures. And usually, deceleration ranges are much more applied to car users in motorways. And I wanted to test with cyclists as well. In Netherlands, because we have much more complex movement with cycles. In Netherlands, it's a pretty huge concern. And jerks were actually applied for the first time with cycle users. And so there's no research found with the application of jerk and measuring the jerk with cyclists. So this is the first time which we actually use that in this project, and we'll see how exactly these two surrogate safety measures help us understand our safety and behavior, of course. And finally, of course, we need to do something and take a measure or create an intervention to actually change the behavior. And as I told you, through cyclists tend to go faster. And so basically, the main motive is to make them reduce the speed and improve the safety. So one of the measures, or actually a very important measure of this project, was something called a transverse lane marking nudge. And here I will explain what exactly do I mean by nudge. So nudge is something which makes the road user change their behavior or make them behave safely in a subconscious way. So if you consider traffic signals we have, they are not considered as a nudge, because when we have a green, we tend to go, and when we see red, we stop, right? So that is not a nudge. But nudges is something which subconsciously changes our behavior without actually reinforcing a road user to do something. So in this case, if a road user travels across this transverse lane marking nudge, which is pretty common for car users in motorways, and I guess there's also a lot of highways in India have this transverse lane marking nudge for cars, and also they have pegs at the sides of the road to actually make the road user subconsciously think that even though if he's going at a certain speed, he subconsciously feels that he's actually moving at a higher speed. So that's the main idea of nudge. So we actually implemented in the cycle lanes for the first time in Europe, so actually make this through road users think that they're going at a higher speed and make them actually slow down when they're coming close to the intersection. So that's the main idea. And yeah, we can discuss more about the nudge and the nudge theory if time permits. So that's more about the state of art in literature. Moving forward, so this brings us to very important objective or purpose of this whole project is to understand what exactly this transverse lane marking nudge have with the behavior and safety of cyclists. And so three important objectives is, of course, to understand the speed, whether they are decreasing or whether it's still the same, and the safety criticality, that is the number of safety critical counts using deceleration and jerk. And finally, of course, we need to translate that into useful policy recommendation and implication, especially with the use of nudge in the future. So I guess it's pretty clear till now. What are we going to see in the rest of the presentation? And we'll be handling only these three aspects. And now I'll explain a little bit in detail about the field study, which I did. In fact, I'll explain with the study location. Again, it's a pretty a rough view of what exactly the T section looked like. And I'll get to the real pictures later. But this will give you a very good understanding of the T intersection. As you can see here, this is a through arm and this is the intersecting right arm. And as you can see, these are the transverse strips which we applied. And there are different measurements which are not quite important for now. But one thing which is important to note here is, as you can see, there is a cycle parking placed exactly next to the lane marking nudge. So this might have an influence. So we just need to keep in mind for now that there is cycle parking and pedestrian path in both sides of the road. And maybe I can give you an actual picture. So this is the T intersection. As you can see, it may not be that clear compared to the previous image. But yeah, this is the through arm, and these are the transverse lane marking lines. And quite important to note here is, of course, the lines are decreasing in length to create the illusion, because we can't trace the lines which are equidistant to each other, and that don't create an illusion. And I think that's pretty understood. And this is the intersecting right arm, which is actually kind of going into the tunnel. So that's the reason I kind of put a picture which just mentions the measurements and a top view. And yeah, so we actually implemented video camera surveillance by hiring a couple of other companies who are good in actually surveillance and video coverage. So again, this is a rough image. So we use two cameras again to capture the movements at this T intersection. So one camera, which is focusing on just the cyclist coming to the T intersection. So basically there are cyclists approaching the T intersection, and another camera which covers the junction of the T intersection. So how exactly does the cyclist and the scooters go after this? Like, do they speed up? Do they slow down? How exactly they turn, etc. So camera 2 is quite important to understand the through cyclist behavior and the turning behavior of the turning cyclists as well, who are going into the tunnel. And main purpose of camera 1 is to understand the behavior, the post behavior of the cyclist, especially the post behavior, like say, for example, 10 meters before reaching the intersection, how are they behaving, and whether they are changing the behavior of safety well ahead. So everything can be captured with these two cameras. And a realistic picture of the camera, you can see in the next picture. So this is the actual view of the camera, and the cyclists are blurred, of course, because of the confidentiality reasons. And so these are, again, I represented it in the picture because the picture was taken before the implementing the lane marking nudge. And another picture focusing on camera 2 is this is an actual view of camera 2. So the main purpose of camera 1, of course, as I mentioned, is to understand the road users approaching the T intersection as indicated by the arrow marks. And in camera 2, I focus on 3 movements. One is, of course, the through movement, the cyclist crossing the intersection, and one movement is, of course, turning. And another movement of road users who are not using actually the lane marking nudge, and I'll explain the significance of this movement a little later in this presentation. And one important thing is also, of course, the video surveillance is captured with and without the lane marking nudge. So for a period of 3 days, we captured the scenario with the lines, with the lane markings as indicated in the picture. And also for a period of 3 days, we captured it without the lane marking nudge to, of course, find the differences about the safety and behavior with and without the lane marking nudge. So that's a very important thing to note here. So, and also, of course, the cyclist trajectories, which we observed, I used a little bit of coding in Python and MATLAB and a few open source modules to actually convert the GPS coordinates and the timestamps we had into trajectories. So in this picture, you can see the actual trajectories of the cyclist. These are the 20 cyclists who are observed from camera 1, as you can see here. And these are different trajectories. So basically, there's a rough idea about how the trajectory data, the camera data, is translated to a trajectory data. So once we have a trajectory data, then we use different indicators and try to actually extract the indicators from these trajectories. And to find what are the different indicators which are required for answering our purpose of behavior and safety, I came up with a very descriptive conceptual model, which a little seems complicated, but 2 important things from this conceptual model which might be useful for the rest of the presentation is actually the 4 indicators which I mentioned in the dark blue color. So the 2 indicators in the top, surrounded by the dotted lines, that is the mean speeds and mean accelerations, will answer how their speeds are changing and how exactly are they braking. And 2 other factors, the critical deceleration counts and the critical jerk counts, answer how safe it is. So basically, all these 4 indicators are calculated with the lane marking nudge, and without the transverse lane markings. So of course, at the end, we compare the data and see what exactly is these lane markings doing. And of course, the main idea of this conceptual model is to, of course, see which factors are influencing, and of course, how this road user behavior can be studied using the different data we have. Like, for example, the individual position is obtained from the trajectory, individual time is also obtained from the trajectory. And there are a few other factors which are, of course, dependent and independent, and which are, of course, used to give the different indicators. So this we can, of course, discuss in detail if you guys want to, have some doubts or need some elaborations. But for now, these are the important things from this conceptual model. And feel free to, again, post your questions with probably the slide number so that we can go back to the presentation. And also, you can also stop by and raise your hand or interrupt me so that we can also discuss quickly if you have some quick doubts. So as I explained, with the surveillance data we have, I initially tried to clean the data. Of course, it's very important to clean the raw data, especially when we perform an empirical analysis. It's quite obvious that there might be a lot of noise and there might be a lot of outliers. Like there might be a few cyclists who are coming out of the parking. There might be a few road users. There might be a few pedestrians who are walking here and there. So it's really important to filter out that data and to have a little cleaner data set before we move forward. And once we have a clean data, I try to subgroup the data into a few categories.
Sorry to interrupt, sir. How far this will be helpful maybe in the local authorities to take decision making, sir? Maybe in...
Yeah, actually, so the main idea is whether this lane markings, especially in unsignalized intersections, have impact on the road user speed and behavior. So if it's found to be useful, then we can actually implement this also in motorways and also in local roads. Say, for example, in urban roads, instead of using, say, other measures like speed breaker, which deliberately makes the road user slow down fully, and then you need to reaccelerate, and this loses a lot of time. We lose a lot of petrol and braking, a lot of pollution. So the main application is to slow down the road user subconsciously without making him actually slow down. So again, the results can be translated into policy implication and recommendations, and then we can tell them, okay, if you use this type of lane marking, it might give this type of impacts. Well, that's the main idea of this project, of how exactly the lane marking nudges can influence road user behavior. Yeah.
Thank you, sir. Thank you, sir.
Yeah, sure. So yeah, coming back to the data. So once I clean the data, then I tried to subgroup the data into, of course, clearly with and without the lane marking nudge, as I told you, to compare the two behaviors. And then, of course, I also used the time of day. So I also thought it's quite important that the road user behavior and safety might be different on a weekday and a weekend, because imagine on a weekday, we have to either catch a train or go to work, and there are different types of trips. So based on trip purpose, the behavior and safety might change. And on weekdays, of course, people might go to groceries, a gym, or people also cycle for pleasure. So there can be different purposes, so clearly. So these are the two reasons why I try to kind of split the time of day into weekday and a weekend. And I also wanted to study a little bit on how exactly the behavior and safety might change on a morning peak and evening peak, especially to distinguish between the home work trips and the work home trips. Of course, it's again a hypothesis that it might be different or it might be same. So that's what we're going to test. And also the road user type, as I told you, I did not include pedestrians here because they don't have any influence on the lane marking. So the two road users here are the cyclist and the moped users. In Netherlands, mopeds mean scooters. So we call mopeds here, and Europe in general, but they are scooter users. And finally, of course, there are different types of movement. And as you can see in the T intersection, there can be a maximum of 6 different types of movement. But I considered only 4 movements, which are quite crucial for our study, which is the upstream movement of the cyclist coming towards the intersection, and the through cyclists who are crossing the intersection, and the cyclists who are turning into the tunnel. And finally, as I already told you, cyclists who are not using the tunnel, but going in the opposite direction of the lanes. And I'll, of course, explain the significance a little later with another slide. So these are different groups. So the main idea is to, of course, study the 4 indicators, which we saw in the conceptual model, and see what happens, right? And also these indicators are not measured throughout the trajectory. So I tried to get some slits or some cross-sectional areas, which you can see in this figure, where these 4 indicators are measured. So I tried to measure all the 4 indicators here with and without the lane marking nudge. And basically significance of A is to just check whether they have any differences well before reaching the nudge. And also at the start of the nudge, in the middle of the nudge, and the end of the nudge. And of course, what happens when they turn and what happens when they go straight. So these are the 5 areas, or we can also say 5 cases, where all the 4 indicators are studied with and without the lane marking nudge to see whether there is differences in speeds and safety. And also for the cross-section area G, as you can see, did not have any lane markings. Of course, it is the lane opposite or adjacent to the lane marking. And there'll be an important significance here, because in empirical analysis, it's always important to have something called a control group, where they have quite important significance, which I'll discuss later. So these are the main areas of study. So repeating again, we calculate all the 4 indicators in these areas and check whether there are differences or not with the lane marking nudge. And yeah, so I'll quickly move on to results and interpretations so that we have some quality time for discussions as well. So as I already told you, there is something called control group road users, which are very important for empirical research, because what exactly does the control group road users are useful for is to check whether there is statistical significant differences with and without the lane marking nudge. So actually, it's pretty obvious that the road users are not using the lane marking nudge. So it should be obvious that they should not have any differences, right? I mean, imagine a road user who has no influence with the lane marking nudge. So why will his behavior and safety change? So that's the main idea of the control group road users, to check whether they have differences with or without this type of lines. And it's kind of expected to not have differences. And if they do not have differences, well and good, then we can say that the differences from the other road users using the nudge or using the lane marking are due to the presence of this lane marking. But imagine the control group road users are actually having significant differences in the results. So imagine the road users not using the nudge are also having differences. So that means that there has to be some factors considered which are not the lane markings, but the differences is due to something else. And if we brainstorm a little bit on what exactly can the other factors be for the differences are one, weather conditions might be a very prominent uh, factor for changes in behavior. Another thing can be trip purpose. Another thing, of course, can be the gender or the age group or the working population, whether they are student or work. So there can be a lot of factors. So that's the main reason of using this control group producers, and we should definitely check their behavior before actually checking the behavior of the through cyclist and the turning cyclist who are using nudge. So with that being said, I'll give you a few graphs and indicators just for discussion purposes, but I'll then wrap up the kind of generic results as well. So with the mean speeds of through cyclists as well as turning cyclists, the control group producers, as you saw on the previous slide, actually are found to have significant differences. So this means, as I already told you before, this means that there have to be some factors as well, which give rise to this kind of results. So in this figure, as you can see, the darker columns represent the nudge, and that is the lane markings, and the shorter columns represent, without the lane marking. So it's totally opposite to what we were expecting from the results, because what happens is with the presence of the nudge, as you can see in all the different cases of cyclist, at the middle, end, or after crossing the lane marking nudge, the nudge scenario seemed to have little higher velocity or speed compared to the no nudge scenario. So this was pretty puzzling initially for me. But then when I looked a little bit into the video data, and it was actually confidential, but I needed some permission to look into the data just to make sure a few things are going right. And I realized that in the no nudge scenario, especially the scenario where we didn't have lane marking nudge, it was actually raining throughout the day, or at least raining for a significant amount of the day. So which means that the weather condition is also a very significant factor when we analyze or interpret the data. So this doesn't mean that the lane marking nudge is trying to increase the velocity or something. This means that with the control group producers results, there has to be other factors considered. And it does seem that the weather had a prominent impact with the speeds. So still, we don't have any concrete idea whether the lane marking nudge is actually making people behave in this kind of way. But if we, again, consider speeds of mopeds, as I already told you, the nudge scenario on Sunday, Monday morning peak, and Monday evening peak had high velocities. And of course, clearly, the no nudge scenario, I strongly feel that because of the rain and weather as a prominent factor, the no nudge scenario had a reduced velocity. But let's go to other two factors, that is the deceleration and jerk as a surrogate safety measure. But in these two factors, I should also highlight that the control group producers did not have any statistical differences. So basically, we can say whatever results we find are mainly due to the lane marking nudge. And as you can see, this critical jerk counts, that is the safety critical counts using jerk as a surrogate safety measure. It was also found to be higher in the nudge scenario at the middle and the end of the lane marking nudge, with and without it. So what exactly this means is it is actually making the road users brake more often. That is the changes in the braking behavior is quite uncertain with the lane marking nudge. And I also interpreted that the lane marking nudge, especially on cycle lanes, can be treated as an obstacle or a surprise for cycle road users, because they are usually not expecting something like white lines suddenly appearing from nowhere. So imagine the road users have been using cyclists for decades of years, and they see suddenly something new, maybe which made them brake even more. And that's the main idea of this lane marking nudge. But we did not intend to make them brake beyond a certain threshold. So which actually made it a little unsafe with the current scenario that they are braking more often, and the uncertainty or the rate of change of brake is also quite high with respect to nudge scenario. And so to conclude the overall results, clearly in the nudge scenario relative to the no nudge, of course, the mean speeds were high. And of course, with respect to mean acceleration, if the road users tend to decelerate, that means with the nudge, they had increased deceleration. And if the mean acceleration was positive, of course, they are accelerating. But with the nudge, they were accelerating with a reduced magnitude. So it kind of seems contradicting here, because I'm saying with the nudge, they are tend to, brake more often, but the speeds are high. You can ask me, how is this possible? Again, these are the mean speeds. So basically, if there are 1,000 road users, the mean speeds were actually quite high, and it's not individual speeds. And also the mean acceleration was tend to be decreasing with the nudge scenario. And also the critical deceleration and jerk counts, where we actually measure the number of safety critical counts, they were also high with the presence of this type of lane marking. But there are a few instances where the acceleration were pretty much same or did not have statistical significance different with the upstream cyclists and upstream mopeds. So which means that the road users are not actually changing the behavior well ahead, reaching the lane marking nudge. So that is not significantly something which might be useful. So with these empirical analysis, as I already told you, I tried to dive a little bit on policy translation, on understanding what exactly is a nudge theory and what exactly are the behavior and safety changes a nudge can apply. And for this, of course, we have our empirical analysis, but it was still not sure of exactly how to apply this type of lane marking. And especially with this case study, it is found that the road users are not behaving in the way we intended to. So if you take the behavior adaptation of this type of lane marking for cyclists, it is currently not going on what we thought about. So I tried to go a little further on understanding what are all the nudges which have been applied in the past, at least past 10 years, and try to understand where exactly are these nudges successful. So at few places, the nudge, or actually most of the places, the nudge was successful. And especially there are different types of nudge. Say, for example, some 3D painting on the road, which actually creates an illusion of a kid. So they're like 3D painting of a small ball or something, which actually makes a road user think that there's a small kid coming. So there are different types of nudges which are already applied in Europe, which was successful. So I try to understand when is a nudge that is this type of marking or some other element, when is this successful and when it is not successful, and try to find the reasons of when the nudge was successful and try to implement those changes or those elements as well when we use nudges in the future. So that's the main idea of analyzing the nudges. And then we come up with the proper recommendations of how to use nudge in the future. And in order to do that, I used, of course, the theory of planned behavior, which is a very common generic behavioral framework. But apart from that, something which is focusing more on nudge is this behavioral change wheel by Dr. Mickey, where she came up with the wheel, which implemented or which actually included 3 factors. One is what is the source of behavior, 2 is the type of intervention function, and 3 is the policy category. So in order to come up with some policy intervention or an element which makes a road user change, we need to simultaneously consider all these 3 factors. And just not only the behavior and the function, but also what type of policy categories are going to affect due to this behavioral change. So this wheel was found to be pretty useful, especially for understanding the way nudge performs. So as you can see, not all the elements are useful for the nudge theory or the nudge we implemented. It's just psychological and it's an automatic response. So these 2 can be considered. And the type of intervention function is actually not something external. So this is there are people are not educated with the nudge, so the persuasion changes and there is no incentives with the nudge. So this can actually be applied with the nudge theory and made sure that we are in line with the policy categories which we want to change. And another behavioral theory which I used is called Mindspace, from Dolan, where he came up with 9 important elements to actually check before implementing some behavioral change or some element. Like this can be generically applied for any intervention change we are implementing, and of course for the nudge as well. So we need to make sure that few elements are quite important and few elements are not, because we are not going to check with commitments, or the factor called ego is not considered here. But the factor called priming is very important for the nudge, because what exactly priming means here is the acts which are influenced by unconscious cues, and this is the core definition of a nudge, right? Because we are trying to make road users behave in a certain way subconsciously instead of making some direct decisions and changing the behavior deliberately. So these two elements were kind of used, and I try to also go through the state of arts of all the previous cases where the nudge theory was implemented and the behavioral frameworks which are used. So these two are pretty generic frameworks, and I think it's pretty applicable for a lot of other safety implementations in future as well. And so finally, as I told you, what can be the key improvements in the nudge? So why didn't the nudge work in our case study, and why did it work in a lot of other previous researches? So I found that the nudge scenario should have been extended for a longer time. So as I told you, the nudges were the road markings, which we put as for a period of 3 days. So that should have been a little longer for a significant change to occur. So that's one of the important findings which I found through literature. The second is we need to have a really strong connection with the intention to behavior, right? Because we intend to do something, but depending on the behavior, the road user, even though if he feels that he's speeding up, why should he actually reduce his speed? Imagine he's going to catch a train and he has some other important intention. So we need to study what exactly are the intentions of speeding behavior, and why does a road user speed up in the first place, and try to slowly come back, try to back calculate what are the things which are affecting the intention, and then coming up with the behavior, and also use some nudges which can change the intention rather than focusing more on the behavior. And it's quite important that if the behavior is not as per expected situation, we shouldn't scrap off the idea and try to come up with a different nudge or different type of measure, etc. We need to check again what exactly are the motivational factors which are lacking behind in the nudge or a certain type of intervention. We need to check that. And finally, we need to, of course, check with the very standard behavioral frameworks like Mindspace and behavior change wheel, which we just saw, and make sure that they're also in line with all the validated projects or all the validated researches that's happened before. So these are two important, of course, validated frameworks, and there are much more as well. So we need to also have a strong support from the theory. And finally, some of the final conclusions, of course, from this case study. So this is basically just relevant to the lane marking nudge used from this case study. So the transverse lane marking nudge still have to be improved. Did not have a strong evidence of reducing speed, nor the safety for now. But we understood what exactly are the problems. So a longer intervention is required, and a much stronger link have to be made from the behavior and intervention to actually bring up with the motivation. And I think I'll take 5 more minutes to just quickly go through the limitations of this research, because of course, every research has its own limitations and the things which could have been avoided or could have not been avoided, but should have been taken into account for the next project. So there was a parking facility, as I told you, so it might impact the results of the lane marking nudge. And we should also consider that the weather conditions probably are, if possible, same with and without the nudge, so that it does not have a significant impact on the results, on empirical results. And the data collection phases was actually done first with the nudge and then without the nudge scenario. So this might bring up some behavior adaptation. So it's always better to do the study or do the kind of surveillance without the nudge first and then with the nudge. But this happened because of few unconstrained or expected situations. And finally, there was also wear off from the transverse lane markings. That is, the white markings kind of came off, at least the last 2 or 3, which actually reduced the entire length of the nudge and making it shorter than expected. So this might also be a reason for the unexpected behavior. And also the video surveillance was a little bit stuck, and it did not run on Tuesday. So I was not able to study the differences from Monday and Tuesday, which I expected to be same, but still it could have been nice if I had a longer video data set to analyze the differences within the weekday as well, considering Monday to be much more penetration of the cyclist or much more cycle users compared to Tuesdays, and that might be an impact. And finally, of course, for the future recommendations, we can do a lot of improvements and a lot of application-oriented things. we can actually take explicit interviews and the stated preferences of the road users who are crossing the lane marking nudge. So this actually makes me realize or think that, first of all, do they have any psychological change, or do they have any subconscious speeding up behavior? And if they have, why did not they slow down? Or what are some lack of motivations which will make them slow down, and etc., etc. So stated choice preference would be really helpful. And of course, these two surrogate safety measures, the deceleration ranges and the jerk, have to be validated, especially jerk, because at least deceleration ranges have been validated for car users and also for cyclists. But the jerk is used in this project for the first time, and of course, it has to be validated. And there are also a lot of applications for jerk. And finally, the demographics have to be taken into account. But because of the confidentiality, I was not able to realize or recognize gender, the trip purposes, or especially the working population and student population, age. All these factors were lacking because of the confidentiality. So I was not able to study any of these factors, which might be an important factor. And finally, of course, we can study the road user interactions from the parking and also include pedestrians, and study how exactly the cyclists or the road users interact when interacting with the pedestrian. As you can see, there is a guy walking. So this might kind of course, have a direct or indirect impact, which have to be studied explicitly. And finally, there was also bidirectional movement. I usually focused, or I actually focused on the through cyclist movement and the turning movement. But there are also much complex movements like cyclists coming out of the tunnel and cyclists coming out of the parking. So there can be different type of studies which can be performed with the other directional movement as well. So with this, I think we come to the end of the presentation. And once again, thanks for listening and taking your time and being a part of this talk. And I think, we have a good time for some discussions. And I think I was more looking forward to this part, in fact. And
Yeah, thank you, Girish. Excellent presentation. So we request the participants, if at all you have any queries regarding this, you can post or you can unmute and talk.
Quickly come back so that we can go to the slides. We have some specific questions.
Hello, sir.
Hello. Yeah, hi. Hello, Satish. Can you hear me?
Sir, I am audible.
Yeah, Satish,
you're audible. Yeah, tell me. Yeah, tell me, Satish. I think maybe, maybe I can also open up the chat if we have some questions there. For this, I need to stop sharing. And also, I feel this can be applied for motorways and, of course, for car users as well, on a much higher scale, because even in urban roads, we see that the turning behavior are pretty complex in India or in Europe, but especially considering the lane following movement in Europe, it was more significant. But of course, it can be implemented with car users or the road users as well. Yeah, that's fine, Satish. You can also post your question here. I will answer. Yeah.
Sir, how often this has to be considering the growth of the traffic? How often this study has to be improved, or how it can be again modified, sir?
Sure. So first of all, I try to understand what are the current problems. So it depends on where are you applying this type of nudge theory or lane marking. So in Europe, we at least found that most of the car users have a pretty much strong lane following behavior here. So they're much more disciplined with the car users, but cyclists and in a lot of other countries as well, it's growing. So the cycle population was penetrating at a much higher rate in Netherlands, Denmark, Sweden, Germany, and they don't have a proper lane following with cyclists. So there's complex movement happening, and different turning behavior, and especially in unsignalized intersection, as you saw in this case study. So there was a clear application for this type of lane marking. But if you ask me in India, especially since we also have complex movements, of course, with public transport and car users and also other road users sharing the same urban lane, and also the lane following is still in progress, especially in urban roads or lots of streets. So I would say we can still implement this, but I think for a higher level of more strategic planning, we have to make sure that at least we try to either come up with a little bit of segregation. Like, for example, we are coming up with metros, which actually takes up a lot of traffic from the lane, and maybe come up with separate bus lanes, or in especially bigger roads. So with current trend we have in India, I think for now it might not be applicable. But of course, when we have a little bit of more lane following nature and separated infrastructure for, say for example, bus or scooters, then I think it might be a very good application.
Thank you, sir.
Yeah, sure. Yeah, sure. Yeah, Satish. So he asked what are the difference between lane marking nudge and non-nudge. So yeah, as I can share the screen quickly. So basically, the nudge is something, it's just type of lane marking in this case. So as you can see in this slide, the nudge scenario is something with the lines, and the no nudge scenario is something actually, kind of the video data we collected is actually initially with the lane marking nudge, as you can see in this slide, and then we collected 3 days of data without the nudge. So the lines will not be there. So that's what I mean by no nudge scenario. So that is used to actually get the differences with the behavior and safety, how the cyclists and scooters behave initially with the lane marking nudge, and after without it, and then try to compare. So that was the main idea. Yeah, that's also a very good question. So T intersection, again, with the literature study and the state of art, I found that there's much more complex movements is one thing, because when the cyclists are going at the roundabout, say for example, when they're sharing or when the lanes are adjacent to the motorways, they have very good signaling system, and they have really good priority. So that was not a problem there. But at T intersection, it was dedicated only for cyclists and scooters, and it doesn't have signal. So there are multiple complex movements. And second of all, as I already mentioned in the literature, that there's an inverted priority perception. So the through cyclists who are actually going the through arm are kind of having a subconscious thought that they have a higher preference. But in Europe, in Netherlands, the right turning cyclist in the intersecting right arm actually have the preference. So this type of priority confusion happens, and there are much more complex movements. So these were the 2 reasons why I chose T intersection and cyclists. Yeah.
Thank you, sir. Thank you so much, sir.
Yeah, sure. My pleasure. Yeah.
Sir, do we have any set of guidelines exclusively for the cycle users, or the same what do you call the traffic rules and regulations to be followed, sir? Maybe in India, maybe not abroad.
Yeah, sure. So in Netherlands, first of all, mostly in a lot of streets, they have dedicated cycle infrastructure and lanes. So it is similar to, of course, the lanes we have for car users. But of course, they have little explicit signs like priority signs. And sometimes if they are crossing an intersection, a 4-way intersection of motorway, or if they are crossing a roundabout, they have separate infrastructure for cyclists surrounding the roundabout. So one really good thing which I saw in Netherlands is it's really separated. So I never cycle on a lane where, especially in streets here, but otherwise it's usually separated infrastructure lanes. So cyclists tend to be a little safer, especially considering car uses. But in the cycle lanes, especially when they are sharing among cyclists and scooters, then it becomes much unsafe, because cyclists, again, as I told you, complex turning movements, and different behavior from the scooters, but then it creates a problem. So that's where our research focused mostly on scooters and cyclists who are actually dedicatedly using the T intersection. So it does not have a kind of connection with the car users here. And also here, there is a very high priority for pedestrians and cyclists. So literally when I cross the road or when there is cyclists coming in, the car users generally slow down and actually come to a break. So because of very high fines, and also there might be high consequences, especially with their driving license. So usually cyclists and pedestrians have very high priority.
Thank you, sir.
Yeah, sure. You're welcome.
Have any other queries? Request the participants. Girish, are you able to hear me?
Yeah, I'm able to hear you, sir. Yeah.
Let us see for one more minute, then we can wind up.
Yeah, sure, sir. Yeah.
Basically, a small question from my head.
Yeah, sure, sir. Yeah,
So
definitely.
normally we see, if you take in India, in 2018 there was a study saying the impact of using cycling or introduction to cyclists is reducing the traffic jams or traffic or congestion, right?
Nice.
But
Yeah,
similarly,
exactly.
there is a study saying there is a huge increment. I mean, there is a huge rise in accident rate with the cyclists. So how do you comment on this? Like cycling,
true, sir.
we are able to reduce the jam and traffic congestion,
Exactly.
but at the same time increasing the accident with the cyclists. How do you comment
Exactly.
on this?
Yeah, that's what the trade-off which we should tackle, sir. So in India, what I think is since we are sharing all the traffic together, like for example, bus, auto, car, everything is kind of shared in the same lanes. That becomes more safety critical for a new type of road user to be adding into the lane. For example, a lot of cyclists, and especially they have different speeds, and clearly, I think the road users are also not willing to follow a cyclist. They want to really maneuver around the cyclist and go around. So that also happens. But in Netherlands, one thing is it's totally separated from the car lanes. So since they have dedicated lanes, I think that's much more safer. But within cyclists, again, it's a problem. But in India, when we start sharing, I think initially it might, as you told, the safety will definitely decrease. And even though if it's helping the congestion or pollution, but I think lives are more important to handle first. And then think about it. But maybe if we slowly widen our lanes and maybe try to come up with, again, it's a far-fetched dream, a pretty ambitious dream. In 10 years down the line, if we have a little separate lanes for cyclists, I think it will be really helpful for them, and much more safer.
Thank you very much, Girish. Yeah,
thank you, sir. Sir, thank you very much. Even though my question, may not be relevant, but being one of the experts, maybe in transport engineering, I wanted to put this question, sir. Usually, it is said that in foreign countries, the driving will be on maybe the left-hand side. Am I right? But here it is on right-hand side. Because of these conditions, do we have any the design maybe in, or we have to consider this in the design aspect of roads and other aspects of other related to roads, sir? Even though it may not be suited to you, but I wanted to hear from you, sir.
Yeah. Of course, sir. Yeah, I don't mind answering questions.
Thank you.
The scope of this, talk. But also, I feel, it's quite the opposite. So in India, we keep left. So here, we tend to keep on the right lanes. And the only difference is, again, the right lane users get higher priority. But like, for example, in India, we have free left. Here, it's, more safer to take a free right. But you're taking a left, then we need to, of course, use the hand signals, especially with cyclists. Here, hand signals are also compulsory. And so pretty much if the cyclists are turning to the right, then they usually, presume to be more safer, but when they're turning left, then they need to consider a lot more things of, cyclists who are coming in the opposite direction and the other aspects. So I think it's pretty much similar to what we have in India. And of course, the designs are relevant, especially since we have priority for the right, and India, we have priority for the left. So I think it's quite like a mirror. So if we follow some rules, and I think if we mirror it and then implement in India, I think it's going to work fine.
Thank you, sir. Maybe the last question to you, sir. Even though many efforts have been taken by the smart cities authorities in India, the cycle program, we presume it deliberately face some setbacks. How do we improve this particular aspect, sir? Because, in Coimbatore, we tried and then, we miserably failed. That is what I personally believe. How do we improve it, sir?
I think one thing here is good here in Europe is they have much more motivation. Like when I say my motivation is, it's pretty much within their community actually to use cycles. So like kids from the young age, they use cycles, and till the bachelors and masters, even some professors actually come with cycles, and they wear their suit and actually come up in cycles. And even I think recently I've seen the news, like the president of Netherlands, he also cycled to the embassy and he signed his resignation in cycle. So one thing which I found is the community was evolved with cycling in most of the cities of Europe. But in India, it's also much more, I think we focus more on comfort, I feel, because when we want to reach from a point A to point B, we see which is much more comfortable rather than which is much more beneficial or for our exercise or for physical strength or congestion pollution. And also in India, it is much more easier to, scooter to, use scooters or, call Uber, which is much more cheaper in India, or take a Ola cab. So I think with the cost and the ease and the comfort factor are pretty dominant in India for the use of scooters, Ola or Uber, or even cars for even solo trips. So, I mean, considering these factors, I think it's important for us to reinforce the thought that from the young age onwards to motivate them to use cycles and maybe include in our curriculum or schools and make it. I think we little more need motivation in that aspect, and also considering the comfort, or it's very hard for someone if they are really comfortable and it's very cheap for them.
It's like a heartbreaking for the young people.
yeah, true, sir. So I think I don't have like exact answer, or even I think I'm kind of
but the only way is to adopt.
Yeah, exactly.
Individually. That's all.
That's true.
Thank you.
But sure, institutions must come forward. Like we see in our NIT culture, and maybe in some IITs, purely we use cycling only.
Exactly, sir. Yeah.
Though it is 800 acres, we always roam using cycles.
Exactly.
So maybe if higher institutions like NIT, other universities and institutions come forward and adopt, definitely all the students may adopt, and later that will cultivate.
Yeah, exactly. So slowly it should come up with our culture, and I think so. It'll
very happy.
Thank you.
Yeah, thank you.
Thank you, Ji. Thank you, Paula sir and Girish sir, both of you for giving the opportunity.
Sure, sir. My pleasure. Yeah, you're welcome.
Girish, thank you very much, Girish. I'm so happy because when your student is teaching better than anybody, so
it's not like that. It's not like that. So come on.
I'm not a full-time teacher to you, but a partial teacher to you, right?
Yeah, in fact, yeah, sir.
I'm so happy.
Yeah, that's true, sir.
So my students also can witness the kind of delivery that you have given, and the amount of knowledge you shared, and the amount of experience you gained. Definitely, it will make some sense to them. Maybe tomorrow they will also become like you. Okay. Thank you, Girish. Thank you very much.
Yeah, sure, sir. It was my pleasure. And once again, thanks a lot for everyone listening to me. And we can, of course, definitely keep in touch. So I can send you the slides and my contact details so that in future, if we want to keep in touch or discuss about some things who are passionate about safety and who want to come for masters abroad, so I'll be happy to, discuss with the students.
Yes, thank you very much.
Sure. Yeah. So
there is a
good
huge
evening
need.
and
There is huge need to improve the road safety for us as a young people. So we need to take this knowledge sharing and experience on this. Thank you, Girish. Thank you very much.
Sure, sir. Yeah. So have a nice evening and good night, everyone.
I request the participants to give feedback using the link provided in the chat. So this is all about the session, and we'll meet tomorrow, maybe around. Let me see. We have a session tomorrow at 5 p.m. again with Engineer Ratnakar Reddy sir, who is a Managing Director of Infra Support Engineering Consulting Bangalore. So let us join again once again tomorrow at 5 p.m. sharp. I request you to join sincerely at 4:50 so that we can sharply start at 5 and end by 6 o'clock. Request you to give the feedback using the feedback link given in the chat box. Once it is done, you may leave the session. We'll meet tomorrow at 5 p.m. on the next slot.